After all these years, I guess I could be forgiven for becoming a little bit skeptical or even cynical about there being any kind of a treatment for multiple sclerosis that's really effective at improving our quality of life and maybe even attacking MS where it lives deep in our cells to get rid of it once and for all. But maybe, just maybe, this time things might be different. Hello and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam and I've been living with multiple sclerosis for 38 and a half years, and I continue to look out there in the wide world of science to find out if anything interesting is going on that we ought to know about when it comes to multiple sclerosis. Recently, I saw a video in my feed that I had not actually looked at before, even though it had been published a couple of years ago. It was from Dr. Bieber, whom I respect a great deal, so I went ahead and looked because the subtitle talked about exciting new research, and I thought, okay, so what was so exciting back then? Is it something worth knowing about?
Bruton's tyrosine kinase inhibitors. These drugs work on B lymphocytes indirectly, but they're likely much less deleterious in terms of weakening the immune system compared to B-cell depleting drugs such as rituximab, Ocrevus, and Kesimpta. One example is the drug Masitinib, and I did a video on that earlier. I really think these drugs could come to market relatively soon, and they could be great options for people who are older with progressive MS who aren't necessarily great candidates for other disease-modifying therapies.
Well, that was very interesting. So I was intrigued enough. I went out and looked at the video that he mentions where he talks about Masitinib for multiple sclerosis. And I'm going to play just parts of that video because he does a good job of explaining the mechanism of how it works and gave me some insight into why it might really this time be something of a breakthrough.
We believe that most of inflammation in multiple sclerosis is driven by the adaptive immune response, the B and T lymphocytes, which specifically recognize antigens or targets within the body. But there's evidence that in progressive multiple sclerosis, much of the injury may be due to the innate immune response, the aspect of your immune system that you're born with. And a new drug, Masitinib, recently demonstrated efficacy in a phase 3 trial in progressive multiple sclerosis. Masitinib is in a very interesting class of drugs called tyrosine kinase inhibitors. And tyrosine kinases in general are transmembrane receptors that initiate a cell signaling cascade. And I'll show a slide in a moment that will make this a little bit more clear. But what they do is they phosphorylate or add a phosphorus to tyrosine residues, which is an amino acid on proteins, and they initiate a cascade of events that affect cells. And Masitinib is a very specific tyrosine kinase inhibitor, which targets CD117, also known as mast cell growth factor, also known as c-KIT. And it's specifically on certain types of immune cells in the innate immune system, namely mast cells, microglia, and macrophages. And as I said, they're very important in inflammation in progressive multiple sclerosis, we believe. And it's not an immunosuppressive medication, at least according to Vermersch, who's the lead author on the phase 3 trial. And this drug is being developed for various other conditions, such as Alzheimer's disease, ALS or Lou Gehrig's disease, severe asthma, and mastocytosis, which is a condition caused by proliferation of mast cells. So it's not currently clinically used in humans. Interestingly, it's used to treat mast cell tumors in dogs under the trade name Masivet. So this is a diagram of the normal tyrosine kinase pathway. This is the transmembrane protein CD117 or c-KIT in this particular case. And normally it binds a ligand and phosphorylates tyrosine, which initiates a complicated cascade of events leading to proliferation, differentiation, survival, and migration of these immune cells, such as mast cells and macrophages. So Masitinib blocks this from happening, preventing proliferation of these cells and hopefully preventing inflammation related to the innate immune system in multiple sclerosis. And one thing that's relatively favorable about this class of drugs, tyrosine kinase inhibitors, is they don't seem to significantly weaken the immune system and are reasonably well tolerated. Research on masitinib began in mice in a mouse model of MS called experimental autoimmune encephalomyelitis, and it looked to be potentially beneficial. And in 2012, we saw the first trial in humans with progressive multiple sclerosis. Now, this was a tiny pilot trial, only 6 people getting placebo and 24 people getting masitinib, but there was a trend towards a benefit. It wasn't statistically significant just because there were so few people, but if you look at the MS functional composite, you can see those getting placebo tended to worsen, while those getting masitinib slightly improved. And if you look at, for instance, the timed 25-foot walk, you can see those getting placebo worsened by 26% on average, compared to only 5% with masitinib. And if you look at the expanded disability status scale, sort of an overall measure of disability in MS, and I have a separate video on that if you want to take a look, you can see those taking placebo slightly worsened by 0.3, where those taking masitinib were about the same after 12 months. And if you looked at primary progressive MS and secondary progressive MS separately, both seemed to be better than placebo, but again, it was not statistically significant because it was such a small trial, but this encouraged further research. And finally, in September 2020, we got the results of a phase 3 trial suggesting that masitinib does work in progressive multiple sclerosis. And this was a larger randomized double-blind trial over 96 weeks, and they studied both primary progressive multiple sclerosis and secondary progressive multiple sclerosis in people who were relapse-free. So they wanted to look at people who didn't have obvious active inflammation. And they studied 2 different doses of masitinib. One was 4.5 milligrams per kilogram per day, given orally divided into 2 doses. And the other group started on this dose and then escalated to 6 milligrams per kilogram per day after 3 months. And they used 2 separate placebo groups just so that people wouldn't know whether they were getting placebo or not. Otherwise, the dose escalation would give away that you were on the drug. And it turned out that for whatever reason, the 6 milligram kilogram per day dose didn't do anything relative to placebo. For whatever reason, that placebo group did particularly well, so there was no advantage to the drug. So we're just going to look at the 4.5 milligram per kilogram per day dose, which is what's going to be used in future trials, and the dose likely if it's ever available clinically. So there were 656 total participants, but in the 4.5 milligram per kilogram per day group, there were 200 who received masitinib and 101 who got placebo. So they did 2-to-1 randomization just so you would have an increased chance of getting the drug to encourage people to enter the trial. You had to be between ages 18 and 75, and the median age in this study was 50, and you had to have an EDSS of less than or equal to 6. So EDSS, again, is Expanded Disability Status Scale, and at 6, you require a cane to walk 100 meters. So you couldn't require a walker or a wheelchair and be in this study. The median EDSS was 5.5, which is a level of disability at which you can walk 100 meters, but not 200 meters without an assistive device. And the primary outcome they looked at was EDSS after 96 weeks. And the secondary outcomes were multiple sclerosis functional composite and multiple sclerosis quality of life. And if you look at this in graphical form, you can see this is the masitinib group, and this is the placebo group. And so they did get worse on treatment, but significantly less worse over the 96 weeks compared to placebo. But what was really interesting is when they looked at how good masitinib was at preventing people from ending up in wheelchairs. So they looked at the probability of reaching EDSS 7, and this is the level of disability where a wheelchair is required for all but short distances. Now, you could only have an EDSS of 6 or less to get in the trial, so no one was using a wheelchair at the beginning of the trial, but a small number of people did end up using wheelchairs at the end of the 96 weeks. And you can see there was a massive difference in cumulative probability of reaching EDS 7. In fact, a 98% lower risk in the masitinib group. You can see the placebo in the dotted line, and in the masitinib group, only a few people at the end were using a wheelchair. In fact, if you looked at sustained EDSS 7, in other words, people who were in a wheelchair and 3 months later they were still in a wheelchair, so not just related to fluctuation in symptoms, there were 0 people in the masitinib group who ended up being in a wheelchair for 3 months or more straight, compared to a small number of people in the placebo group. Now, of course, this is very small numbers. You can see that only 5 people ended up with a sustained EDSS-07, but they were all in the placebo group. So there are 3 things that really impressed me about this research. One is that it completely works in a different way than other disease-modifying therapies. It has nothing to do with the adaptive immune system, and it seems that we really underestimated the importance of the innate immune response, especially in progressive multiple sclerosis. The second thing is the relatively favorable side effect profile. Some people just aren't great candidates for certain types of disease-modifying therapies. They may have a lot of comorbidities. They may be very susceptible to infections already. So if this drug, Masitinib, truly isn't an immunosuppressant, which I'm not wholly convinced of, that would be very favorable. The last thing is that I'm impressed that this drug seems to prevent people from reaching higher levels of disability. For a lot of other disease-modifying therapies, there's evidence that they work best in people with lower levels of disability, but we need something for older people who may already have significant disability, who may not have relapses or make new MRI lesions, and the data on reaching EDSS-7 was very impressive and provides a lot of hope to these people, in my opinion. Of course, it's not enough to do it once. The drug company must do it twice to get FDA or EMA approved, so I'm sure we'll see a second phase 3 trial, and I look forward to those results.
Well, and then just coincidentally, I guess coincidentally, I got something in my feed about the FDA approving this very drug for human use. And of course, that begged the question, what's going on in those clinical trials? And I'm not going to go through them, but I'm linking the page down below so that if you want to find out more about the clinical trials, you can go to that page and find that out. Interesting, I have to say. It looks like the safety and the efficacy have been proven, and it's now in kind of the final stages where pretty soon we might even be able to see it being prescribed by doctors and being used in the public world of multiple sclerosis and not just in the laboratory. But wait, there's still more. Because if you have been following my videos, or if you follow Professor Gavin Giovannoni at all, you know that his belief, his firm belief, is that MS is caused by Epstein-Barr virus, that you cannot get multiple sclerosis if you have not been exposed to Epstein-Barr. And so I'm thinking, okay, does this BTK inhibitor actually help us with the smoldering MS that's still in our systems thanks to Epstein-Barr virus? And here is what I found, a video from Dr. Giovannoni saying this.
A new class of drug has come out, is been tested in MS. It's called the protein tyrosine kinase, or BTK inhibitors. And this is a really important molecule for activating and keeping B cells alive. And very interestingly, in the EBV, in its latent phase, produces a protein called latent membrane protein 2. There's 2A and 2B, and this sits in the membrane. But what's interesting is this protein actually signals via BTK, and it requires BTK to keep the B cell alive. And so if you inhibit BTK, you're actually working against Epstein-Barr virus, because those cells will lose their signal that keeps them alive, and they die. And there's pretty good evidence now from experiments done in the lab on cells that protein tyrosine kinase inhibitors, BTK inhibitors, are pan-anti-EBV. So I think it's quite exciting that the BTK inhibitors are being tested in multiple sclerosis, and I think we shouldn't just assume that they're working via B-cell biology, but they may be actually working as antivirals. Isn't that interesting?
Isn't that something? But wait, there's still one more thing. I saw another article that talked about the possibility of using this same BTK inhibitor, Masitinib, to prevent or treat not just COVID, but many other viral infections. And that would make sense, I suppose, since EBV is a virus. But I'll go ahead and pull this up so we can take a look together at what this article has to say. Okay, it says existing drug is shown to inhibit virus that causes COVID-19. This came out in August of 2021 from the Argonne National Laboratory. Scientists from the University of Chicago have found that the drug Masitinib may be effective in treating COVID-19. The drug, which has undergone several clinical trials for human conditions but has not yet received approval to treat humans, inhibited the replication of SARS-CoV-2, the virus that causes COVID-19, in human cell cultures and in a mouse model, leading to much lower viral loads. And so the research team that's from the Argonne, they also found that the drug could be effective against many types of coronaviruses and piconaviruses. Because of the way it inhibits replication, it has also been shown to remain effective in the face of COVID-19 variant. And of course, I went out and looked at the clinicaltrials.gov website, and there are indeed 2 clinical trials ongoing. They're recruiting for this sort of connection between COVID and Masitinib. They're being done mostly in France, in the Russian Federation, nothing here in the United States yet, but at least it's a start. I'll put the link below so you can check them out. Well, after all of that, I don't know. I can't help it. I'm feeling guardedly encouraged. I think if you know me at all, you know that I'm pretty slow to get excited about this stuff because one minute you hear that it's going to be the greatest thing ever, and the next minute you hear that, oh, well, never mind. So we're going to move on to something else because it didn't work. Yeah, you get a little bit jaded after a while, and you just don't want to get your hopes up too far. That's certainly been the case for me. But this looks different somehow because it's so broad-ranging. It seems like it might kill like 3 birds with one stone instead of 2. I don't know. Only time will tell. But again, as I've said in other videos, part of what gives me the assurance that there's some good science going on behind this is the wide variety of science teams in many countries that have been looking at this. And so if all of them are kind of coming to similar conclusions, I think that means something. Well, let me know what you think. Is this something that you would get excited about if you were offered the chance to be in the clinical trial? Would you? I think I would, actually. In fact, I have a message in to the woman who ran the clinical trial that I was just in last summer, because when we were talking, I asked her if she was going to do anything with BTK inhibitors, and she said that she was seriously considering it. So I've asked her about this one in particular, if OHSU could get involved in doing clinical trials for this phase of the study. And if I hear anything back, and if I get in the trial, I will certainly let you know. I am very encouraged, partly because there are no serious side effects associated with the use of this drug, and most of the other ones, you got a downside, right, that you really have to take into consideration, and this one doesn't look too bad. So as I said, I'll keep you posted, but in the meantime, yeah, let me know what you think, and until I see you again in my next video, take really good care of yourself.